Okay, can you hear me great in the back? Okay. So yeah, I'm Victor. I'm one of the 5 guys maintaining Docker and maintaining the community of Docker. And today I'm here to talk about why we decided to choose Go to make Docker. So first, I would like to say Docker is not only a project, it's only a huge community. We have more than 11,000 GitHub stars, more than 400 contributors. Half of the commits are not done by the company, but by like outside contributors. And I recognize some of you in the audience, like Paul, Vincent, Ivan, or Mark. And I really want to thank you, because without the community, Docker wouldn't be where it is today. And it's also because of Go, and it helps a lot. So who knows Go? Who knows Docker, sorry. Who knows Docker? Okay, cool. Not everybody, so I will do a quick introduction about what is Docker. Some of you probably already saw the next slides, but just a few slides after it will be a completely new talk. So Docker is trying to solve an issue. We like to call it the matrix from hell. So basically, as developer and sysops and sysadmin, we have to ship tons of stuff, like a Go application with a MySQL database, or a Python web stack with a Redis database, to any kind of machine. So it could be your Ubuntu laptop, your Mac laptop, an OpenStack cluster, or anything. So that's the problem Docker is trying to solve. And to solve this problem, we'll take a look at the past, at another matrix from hell, the matrix of shipping goods around the world. So when you want to ship, I don't know, French wine bottles around the world, you don't know if it will go by train, by truck, by boat, or anything. So how did we solve this issue? In the early 60s, the shipping container was found. So it's really nice, because when you want to, I don't know, to ship coffee grains, you just put your coffee bags into the shipping container, you seal the container, and then you give it to the train guy, to the crane guy, and they will move it around the world. And at the other end of the world, you just have to open the container, and you have everything inside. So that's how this matrix was solved, and we decided to do the same thing with software development shipping. So we use Linux containers, so it's the same analogy. When you are a developer, you just have to care about what's inside the container, so you put your code, your dependency, your packages, everything you want inside the container, and then you can give it to the ops team, and then they will just run the container, and they don't have to care about what's inside. So yeah, that's how we solve this matrix. So you can see containers from 2 points of view. The first one would be lightweight virtual machine, because in a container you have your own process space, you have your own network interface, or your own IP and everything. You can run stuff as root inside a container without messing with your host. It's totally isolated. And you can specify your own SBIN in it. So basically, if you want, you can boot your container. So it looks like a virtual machine, but on the other end, it's more like CH root on steroid, because you don't have to boot a container. And basically, a container is just a bunch of processes isolated from the host, and they share the kernel with the host. So you don't have to boot a container. It spins up in a second, and it's almost as fast as just running a container process. Sorry. So now, what's really Docker? Let's see a few examples. Basically, on your host, you install Docker. Then you can do Docker run Ubuntu bash. So this will spin up a Ubuntu container and run bash inside it. The -it just give us a proper working terminal. But when you do this Docker run, you see you are root inside the container, so you can do whatever you want. You can remove files in varlib or anything. You can't mess with the host. And if you do a PS, you see only 2 processes, bash and the PS. And as you can see, bash is PID1. So yeah, it really looks like a VM. You can run your own application inside it, and it can't mess with the outside. Another example would be, for example, to run pre-baked image. So we have such image like Crosby Michael /Redis. It's a Redis server image. So you just Docker run this image. -d means in the background, and so you get the container ID. So in your machine, you have a Redis server running in the background. And if you Docker inspect this ID, you see that the container has its own IP address, and that its Redis port is forwarded to this port on your host. So, Docker is not only a standard way for containers, but it's also a place to share them. So I told you, you can pull an image, like I did with the Crosby Michael /Redis image, from our public index. So you can see it in like an app store for any kind of application. Then you can run it. If you want, instead of just running the Redis server, I could run a bash inside this image, do some change. I can commit those changes in a new image, and then I can push the new image with my changes in either of the public registry, or you can host your own private registry and like deploy your application like that to your public servers. So, quick example, maybe it will be better. So on my laptop, I don't have Go, and let's say I want to have a version of play.golang.org locally on my machine. So I go to our index, I just look at Go Play, so it will list me all the images. If I took the first one, I can see how it was created. So basically, just from an Ubuntu container, you install Mercurial and Build Essential, you clone the Golang repo, you make it, and you say, when you run this container, I want you to run this command by default. So go run Go Play on the port 3999. So if I want to run the Golang playground locally, I just have to do a go run of this image, and -p means redirect the port 1400, 2000 of my host to the port 3999 of the container. So if I do that, and I go to localhost, I have the thing working, and I don't have to install Go on my machine or anything. Everything is inside the container, and it's working. So you see, it's really easy to just pull a pre-baked application and run it. So I already had the application on my system, but if you don't, when you do the Docker run, it will pull it automatically. So it's pretty fast. So you see, running the application was really fast. So why did we choose Go? So I know we had lots of talks about this already, but it's kind of different for us because we are a huge community. We have lots of restrictions from the outside, from Linux distribution and everything, so it can be interesting. So the first point would be, because it's not Python, it can be silly, but before being Docker, we were a PaaS company called .cloud, and we used containers for years, and it was working fine, but all of our stack was in Python. And we decided to rewrite it because sometimes it's nice to clean up things. And you know how it is when you stick to the same language, you start by just copying a utils function, and at the end you have half of your old code base into the new one. So we had to choose a new language, and Go seems a good choice at the time. Also, adoption by ops people, because when you are a Ruby shop, you don't usually like to run Java application, or when you are a Python shop, you don't use Node or stuff like that. So having a single binary that we can just drop in any server was a huge win, and like there was no issue with it. It was really great at first. Then when we became really successful and we had to package Docker to many distributions, we had some issues because some Linux distributions don't want that we handle the dependencies ourselves. So we had to create a dynamic binary just for those distributions because they want to use the old packaging system like apt-get and RPM themselves. But it's still a huge win to have one single binary. And if you want to try Docker today, you can just get the binary and run it, and it's nice. So Docker is working with client-server architecture, and so it's the same binary. So yeah, it's really easy. You just have to wget chmod, and you can start playing with Docker. Also, when we started the rewrite, like a bit more than a year ago, Docker wasn't that famous, and like Ruby has its slower haters, same for Python or any other language. But for Go, nobody was strongly against Go, and it was really a good sign, because everybody would give Docker a try because it was like neutral, and really wanted that. Also, it's really easy to contribute. As we said, it's really easy to read. It looks like C. GoFMT, it's really nice. We already talked about that. Not having to argue with space or tabs or any style issue. It's really nice. And yeah, I have the perfect example this morning in my mailbox. So somebody just pushed a fix to Docker on GitHub, and he said, I just completed the tour of Go and felt competent enough to fix that issue. So that's something we couldn't be able to have with another language like Ruby or Python. Like Go, it's really easy to understand, and at least the basics. Some complex concepts are harder, but the basics are really easy. And that's why we have so many contributors and so many great people helping us, and it's really nice. Also, CGo. So the Go standard library is great, but in Docker we are doing some low-level stuff, and we had to bind like C SQLite bindings or device mapper and Btrfs, which are like file system. So we really need CGo. Also, the packaging system is great. So we took an example at Camly store, and in Docker, in our main repo, we have a pkg folder with lots of Go packages that you can import in your own codes that are not related to Docker at all. There is no import Docker inside them, so they are just small packages. We have lots of them. We have a package for users that does not rely on any library, just basically it passes the etc password. We have listen buffer also. This allows you to start listening for connection, but just buffer the request until you are ready to process them. We have cgroup package, label, apparmor. So basically, some core functionalities of Docker are put in those packages. So I don't know, even if you don't want to use Docker, you can still take a look at those packages, and they are really useful. Also, some drawbacks because Go is great, but it's not perfect yet. First, we talked about it, but GoGet for us was a really big problem, because first, as we said, you can't fetch a particular revision. So when you keep depending on master of your dependency, it's bad, because if the dependency updates, your project won't compile, obviously. But we have also, as we are an open source project, another issue. Like, for example, if we have one contributor who was working on a project using SQLite a year ago, so he probably has the SQLite package on his system. And if today he wants to compile Docker, he will get Docker code. But it won't compile because he has to manually do a goget-u to update the SQLite package. And yeah, we have so many people trying to hack with us on Docker. It was really an issue for us. So we dealt with that by basically we vendored all of our dependency in the Docker repo. So we have a vendor folder with all the source code of our dependency. And we have also a shell script. Basically, it works like GoGet. So you just say, I want this package. It's using Git and this revision. And it will fetch it for you and put it in the vendor repository. Also, as you can see, we are vendoring the archive package from tip. So I will explain that later. But yeah, we also vendor some other packages. Also, the flag package for us was a big issue because it doesn't handle short option and long option, and it doesn't handle option grouping. So at first, we were using the flag package because it's built in and it's nice, but we found some limitation. And we kind of have the same spirit as Go. Even if we are not in 1.0 yet, we don't want to break people's stuff, so it was not possible for us to just move to GetOPT or CLI or anything, so we had to come up with something. So we created the mFlag package. Basically, it's a fork of the flag package from the Go standard library. It's almost a drop-in replacement, just the flag package from Go takes a name, and our package takes a slice of names. But besides that, it's almost the same. So it does handle long-short option. It also handles option grouping. And what's interesting for us also, you can hide flags from the usage, but still be able to use them. So that's how we kept the old flags working without showing them. But if you had a script like interacting with the Docker CLI, and you didn't see any change when we switched to the new flag package, because all the other was still working, and it also displays a nice warning saying, please stop using the 1- format and switch to the double dash, because this one will be removed. So that's how we dealt with that. Also, Go is still a bit young. I won't dive too much into details, but the syscall package has some stuff which are missing. For example, the send message, so it's a syscall. The wrapper around it doesn't return the number of byte you sent. So the syscall does it, but not the Go wrapper. So there is an issue about that. It will be fixed, but right now it's not. And same for, it's quite complicated, but the receive message doesn't pass one macro, and there is no way to pass it with a syscall package. So we had to fall back to CGO for some stuff. We also found a few issues in Go itself, in the tar package mostly. So we made patches upstream. We open issues in the Go repository. We also, so before we were building Docker of tip, but it was not that good. But it was the easiest way for us, so we build off tip. And right now we are building off the last stable version of Go, but we vendor some packages. For example, we are vendoring the archive package because the patch we made is not in 1.2.1, but it's in tip. So instead of just building off tip, we just take the package we want and we vendor it. Also, we have some issue with the testing framework. Because it doesn't have cleanup or destructors. So one practice we were told is to use a file like z-file.test.go, because test files are processed alphabetically. So it's nice if you put a cleanup in that file, it will be executed at the end. So it's cool. But when you want to run only one test with -run, obviously it doesn't work. So right now we are still with that z file, but we might change to another testing framework soon. And now I want to do a small demo of a website I did that uses Docker. So basically, it's a website that intends to work like godoc.org. So you do godoc.org/package, but instead of displaying you the doc, it will display the code coverage of your package. So code coverage. To have the code coverage, it requires to run the test, and running the test means running untrusted code on your server, so you don't want to do that. You don't know what the test is doing. It can mess up with your system or stuff like that. So this website, each time you want to see the coverage of a package, it will spin up a Docker container. It will get the package, run the test, and then send back to you the coverage. So for example, if you want to see, I don't know, GetOPT, for example, I add it in cache. If you want to see Martini, for example, bad example. Okay, so normally it's not that fast because it spins up a Docker container, and so it takes like, I don't know, 10 seconds or something, but basically it spins up a container, gets the package, test it, and give you back the coverage. How do I change the font to something smaller? Yeah, so basically you can see the coverage. So this part of the code is not tested at all. This part it tests a lot. a bit. This part is test a bit more. And you have dependencies, like all the package used by this one, so you can jump from, yeah. So this one I didn't have the cache, so you see it will fetch the code, so it's pretty fast. And yeah, I guess it can be interesting to see it. So just to go cover.io, it's live. You can test it, and any kind of package, and it will spin up a container and display the code coverage. So I think I'm done. I will know if you have some questions or anything.